On the second problem, it gives us three functions of v, a, b, and c, and they may represent an autocorrelation function of a WSS stochastic process by setting v equals to tau, or a spectral density function by setting v equals to omega or both. So we need to find out which functions of f of v may represent either or both. Explain your answers. So for the a function a, we can get that the e to the power of negative absolute value of v is even, and the e to the power of negative absolute value of v is smaller or equals than the e to the power of negative 0, and the e to the power of negative absolute value of v is equals to is the same as 2 alpha over 2 alpha alpha squared plus omega squared over 2 alpha, which is non-negative, and therefore it represents an autocorrelation function. And also the e to the power of negative value of absolute value of v is greater and equals than 0, therefore it's a power spectrum function. It's a power spectrum. And for the function b, which is f of v equals to sine v squared over v squared. First, the sine squared tau over tau squared is even, and sine tau squared over tau squared is smaller or equals to the limitation of sine tau squared over tau squared equals to 1, and it is non-negative, so therefore it represents an autocorrelation function. And secondly, the sine omega square over omega square is greater and equals to 0, and therefore it represents a power spectrum. And for function c, we can see that it is f of v equals to 1 if the absolute value of v is smaller than smaller or equals to a, and the f of v equals to 0 if the absolute value of v is greater than a. So firstly, according to Fourier transform, its transformation is 2 times sine alpha omega over omega is not non-negative, therefore it cannot present an autocorrelation function. And secondly is that the f of w is greater than 0, therefore it represents a power spectrum.